Welcome to Build with Naz. I'm Naz, the author of the Rebel Open Core repo and the author of developerlife.com, which is a developer website that has been around for, I think, over 2 decades now. In this video, we are going to, this is part 3 of a 3-part video where we explore Linux TTY's processes and signals with Rust. The first video was kind of background knowledge on this kind of stuff. If you haven't watched it yet and you want some background information, that's a really good one to watch. Then the second video was a live coding video where I covered IPC sending and receiving signals in Rust, and that was both sync and async. We use a signal hook crate to receive and send signals, Tokio crate to receive some signals, and proc spawn to create and manage child processes, control their standard in, standard out, standard error, and also use IPC channel to create a very sophisticated way of sending messages across process boundaries beyond what's possible with signals. So that's part 2. Part 3 is all about the Tokio process, Tokio process module and the command struct. So this is the async version of the one in the standard library. So there's a standard process command. This is the async one. So in this particular video, we're going to cover 5 examples. We're going to live code them. Actually, one of the ones is just an example in a different crate, which I will not live code because it's kind of complicated, but I will walk through the code in detail. And essentially, we're going to be building something akin to our own shell. So if you've ever wondered how shells work under the hood, this is kind of like we're going to be building our own async shell, or at least the building or the pieces that are parts of a fully functioning asynchronous shell. There's a crate called Rebel Terminal Async, which I've created, which allows anybody to very quickly create REPLs and shells in Rust that are async. So yeah, with that, let's get started with the first of the 4 examples that we're going to live code in this video. So in this first example, we're going to just take the output of, we're going to write a program that runs echo, and it takes the output of that program and puts essentially, we can capture that output. And that's essentially it. The only interesting thing here is that it's going to be done asynchronously rather than using the standard process command crate. This is just to get familiar with how to use this thing, the Tokio process. And then there's other examples that are far more interesting. So let's see. Let's try the very first simple one. This is, and unlike the proc spawn, everything in this particular the proc spawn example, which was in the previous live coding video, part 2 and part 3, this one, everything is going to be asynchronous Rust. So let's make one of these. Okay, and then I think pretty sure all the dependencies are all in there. Yeah, for Tokio. Excellent. And so let's dump some documentation of what we want to do. So here is an overview of what we would like. So we have essentially we have the a main program which is going to be asynchronous, that will use Tokio process command and then configure the standard in and standard out, much like we did with proc spawn, but this time it's for we're not spawning a child process of self. This is just going to be using Tokio process command in asynchronous manner, configuring the standard in, standard out, and then actually executing this command, external command, and then waiting for it to complete. So first thing we need is a Tokio main. Let's see, async main, and we're going to be using niet because it's super handy. And let's see, that should do it. We can do to do. All right. Actually, we can just do OK. This is, yeah, that should work. Let me do this twice. Okay. For some reason, it refuses to import this one. Is it repo? RSUtils core, and I think it's okay. Yeah, okay. I don't know if that's a Rust analyzer thing or what. So here, let's do this. First thing we're gonna do is let us make a macro. This will become apparent in just a second. And this macro essentially allows us to call Tokio process command, which is this thing. And so normally you would just create a command, and then you would pass it a bunch of arguments that are part of the command line arguments, and then you call spawn on it. So here we just want to do this part of it. We don't want to call spawn or any of the other functions. So let me, and then we have to call wait, and then await it, and then essentially we can do stuff with the if we have the standard in and standard out piped, we can read that. So like this is an example of that, where we spawn echo world, but we capture its output. So make a command, and then there's such a thing called the output function. So there's a couple of ways to do this. We can also do, let's see, we create a command here for cat. We set a standard out to this pipe, which means it's a data structure that will be populated when this command actually dumps stuff into standard out, which is pretty cool. So then we can programmatically retrieve it later and do stuff with it. And here it's a buffered reader that's essentially reading the output into a string or one line at a time, and then we just wait for it to execute. So there's a lot of good examples here. So to kind of, let's do this. Let us look at the command actually. So this is the thing that we're going to be doing. So essentially what this macro does is that it just creates a new command and sets the command line arguments. And the reason it's a macro is because just to kind of escape a whole bunch of ownership things and typing constraints. So because this this is variable number of arguments, and we just want to get this command and then call a bunch of other methods on it. So here we can make a version, let's say, where we just run the command, but we do not capture its output. So let's stub that out. We can say run command, no capture, and we can await it. And then another version where we say run command, and then we can say capture output. So we'll just stub these out, and for now let us do this one. And let's see, this is a to-do basically. So let's do this. So let's make a new async function. We're going to do run command no capture, and that actually is mostly correct, I think, except for the expect. So what we want to do, let's just delete all this. So this is that. If you look at this, the type is it's a command. So let's do this. So we have let's see. So we have a command that gets created by this macro of type command, which is this thing. And then what we can do is we can, using methods, we can just like in proc spawn, we can set the standard input, error, and output. So here we're just gonna explicitly tell this thing to, let's see, process standard IO and then inherit. So what this means is that whatever the current process's standard error is, to simply inherit it. Normally we just leave these out because this is the default, but this is just to be explicit, since we're just gonna playing around with the API surface at this point. So here we can say, if we say null, that means redirected at dev null, like we don't really care. Inherit just means just whatever it is, just use it. And then we can do standard out, and this is also going to be inherit. So this actually just creates a command. So in order to run the command, we have to call wait, and then we have to await it. So it's so actually, let's see, let's do this. This is not supposed to go there. This is supposed to be like this, yeah. So let's see, yeah. So here's this is very important. So even if we call spawn, where is it? Yeah, even if we call spawn, like nothing happens until we await. So we spawn it, it'll do a bunch of stuff. Then we have to call wait and then await it. So it's a little, the life cycle is a little bit, I don't know if the most intuitive thing, but it kind of makes sense in the context of async why it's done this way. So we can do into diagnostic to turn into me at report, and there we go. So in other words, we have a child where we've noticed that when we can do this way. We can say this is command, and in order for that to do something, we say child, and then we convert the command into a child, basically. This could be like yet another breakdown, and then so even though this child has been created, we have to wait for it to complete, and otherwise nothing happens. So it's, yeah, we have to do this and await into diagnostic. That's right. So there we go. This is the sort of like the pattern for this Tokio process command. There's shorter ways of doing this, but for all the examples, I'm going to be sticking with the same pattern, so the code will seem familiar. Okay, so here, let's see this. So we're not capturing the output of the command, and so whatever this echo hello world is essentially we can't do anything with it programmatically the way it's set up right now. So what we can do, so we can't make any assertions because we haven't really captured the standard out. But what we can do is the child struct actually gives us a actually let's do this. It does give us an exit status. So if we, yeah. So this is kind of like breaking out the life cycle in a very transparent manner. So there aren't any niceties or any kind of sugar that the API, we're not using any of the niceties. It's kind of making it very explicit. So now that we have an exit status, even though we don't have the standard out, we can now programmatically check to see that it is actually success. And what we can do at the very end is we can put the exit status. So there we go. So this is our most basic sort of hello world program. So let's see, when I run it, let's see what happens. Wait for the compiler. I had to get an AMD Threadripper machine at some point to speed up the build process. Let's see. Why are there so many errors? That's just strange. Let's see what's going on. We have... That doesn't look right. Let's see. Can't be 1,000 errors. What is this? Oh. Let's see. Command. So does Tokyo process? Okay, so where is this being used? Okay, let's do this. Let's just kill all the Rust analyzers and the VS Code servers. And then let's do this again to see if we can get the errors. Nope, it's still showing 994 errors. That's weird. Okay, doesn't like that. Oh, I think I know what's going on. I think separating this was not a good idea. So we can just do it like this. Let's see if that works. So now we have command. Actually, this is not command anymore. This is child. So that should work. Let's do cargo clean and cargo build. Okay. Let's do that. Yeah, I think that was a problem. I think there's a reason why the macro was, yeah, I don't think it's oh, and then this got mutable. Yep, let's do that. That should fix it. All right, yep, that was the problem. So let's do cargo run bin, and we want, what is the name of this file? Async. Yeah, so it goes hello world, and the exit status is 0. A 0 exit status means success, not 0 means error. So that actually worked. And the reason it didn't work before, when I separated out this, I said, I think, let child equals command, and then put like, I put, I think just that. Yeah. This is also mutable. That errored up because exactly. So essentially, oops, that this thing, I think what's saying is that we need to do like let mute binding to just command. And then we can say binding something along these lines. Nope, that's still not. Oh, that's weird. Because let's see. Well, actually, let's do this. Let's just use the full. Let's see. We can see Tokyo process command, and then I think we do new, and then can do, let's see, how does this work? Where is new? SH, okay. 2 arguments are supplied. Let's see. So new.arg, okay, I see. So then this is new, and then we do .arg. Can we do args? Let's see if that's a thing. Yes, we can do args. So we can do args. then do like that. Oh, still doesn't like it. Interesting. Tokio process command temporary. So interesting. So just new. Let's see. Oh, and then I think we can say, and then so arg.arg, and then we can also do, I think, like that. That should work. Then what does this return? Oh, mutable command. So it's just mutating the OG. So this one is command, and then that should work. Okay, so that works. This is without using that macro, where we just basically create the command and then the args. So I think the problem with this macro is that because the arg is yeah, you know what? Let's just get rid of this macro. I don't think this macro makes any sense. Let's just move on. Okay, this is better. There we go. So we are actually, we can replace this with .args, I think, instead of doing .arg. Oops, we can do like this. Then ditch this. There we go. I like this better. I think this is a lot cleaner. So we create the command, which is this Tokio process thing. And actually, what we could also do is just here do this. We can say let it equals this, then it is whatever, and then we return it at the end. This is a little bit cleaner. And we can do mute because that is mutable, and then there we go. We get our command without that macro. So we create the command, and then we set the args on it. Actually, I don't know why this is on a separate line, but it's kind of like this. Oh, okay, that's the way it likes it. Maybe that's, there we go. Okay, so then we call .args on it, and then that just returns like a mutable. If you look at this, it's just not returning anything. It's just mutating the given command, and then we return it. So we make it, do a bunch of stuff to it, and then return it. And I think that's, so I mean, instead of that, we could have also just done this. I mean, that works too. So let's see. Actually, that's fine. Okay. So then we create a child by spawning the command. That's the child process that is returned to us, and then we wait for the child process to finish, and then we make an assertion that it was successful. So let's run this, and it should work. Yeah, I don't think that macro really added much value, except to make things a little bit confusing. So let's just do that. Actually, let's see this one. Yeah, okay. So, all right, so we got that, and then I think the next function I think we have to implement is this one. And here, unlike this first one, we will capture the outputs. So here it'll go something like, let's write the comments first. So it's going to be like async function run command capture output, and let's see. Actually, let's put a few things to make it clear which function is running. So let's do this. Oops, that was just using print line and then calling a cross term function called blue, which will make it blue. And then here we can do similar thing. So We're over here, we're calling run command no capture, and here we're calling run command capture output. Okay. So here we do echo hello world again, but this time what we'll do is that for standard in, let's see, standard in, we're gonna actually we can inherit, like we're not gonna really do anything with say we can actually make this null. That works too, by the way, but whatever, we just call it inherit for now. Standard out is the one that's the important thing. What the heck, we just make this null. So so here actually let's just stick with inherit. Null is nice if you don't care about it at all. This means that if there's an error, it will be dumped into the same terminal where this binary is running. If we make this null, we won't see any output. So here, actually, sure, let's do this. Let's do null for this one. So we can see like using inherit and using null and how they're different. So then I make a child by spawning it, and then I say wait with output, same as before. And then what we could do here is that, so here when we did wait, we didn't say wait with output, we just said wait, and that just ran the thing, and that was the end of that. Here we said wait with output, and what that does is that it will create this output struct, and then we can interrogate the output struct to get what actually was dumped into there by this echo process. So let's see, what is this? Oh, this mute is not needed. Okay. So let's run this. We should see two things. Okay, so we got run command no capture. That's the first one. Hello world, exit status 0. And then the second one is run command capture output. And here we see hello world with a new line, character line feed. So that actually, we were able to grab the thing from the standard out. And notice that when the standard out happened, it didn't actually dump hello world to this terminal window. It was captured programmatically, and then once it was captured, we were able to then look inside of this output struct. So we can go look at the output struct to see what that's all about. And let's see, output, I think we said wait with output. Yeah, so let's go with output. So here we can see returns feature, return an output containing the exit status, standard out, and standard error of the process. The return feature will simultaneously wait for the child to exit and collect all remaining output on the standard out, standard error handles, returning the output instance. So super handy. By default, the standard and standard error inherit from the parent. And if we want to overwrite that, we can just do standard IO piped, which is what we have done here. We did null. That means that, you know, even if you produce something with standard error, it would just be, we can't access it anymore. It just goes to like the equivalent of dev null, maybe metaphorically speaking. But we are able to capture, because we said piped for standard out, we can then grab it from the output struct's standard out field. So let's see here. Output. There's the standard process output. Oh, I see. That's just not even a Tokio thing. That's just a regular standard process output. So that's handy. So this one is just standard process output, not Tokio thing. Yeah, because here we're also using standard process IO. So here, let's do this just to make it explicit. Can do standard process output. Seems a bit strange to be explicit about it, but it's kind of like a hint that what we have here is not the anything special provided by Tokio, but the you know, the standard process. I wonder if that's the same for, yep, that's the same for exit status. So exit status. Okay. So yeah, these are just standard process, not Tokio. Just like this is standard process. That's why I'm putting the full path to the module, just to be explicit. So yeah, there we go. This is a very simple example of running echo hello world. So basically we're running echo hello world like we would in a shell like this, hello world, and then instead of running it in shell directly, we're putting it in a Tokio command. And echo, by the way, which if you say which echo, it's a program, it's a binary user bin echo. It's not like the cd command, which by the way is an internal shell command. That's because of the way commands work or processes work in POSIX, Linux, Unix, Mac OS. It's not possible to create a cd external command. It has to be an internal command for the shell, because the current working directory, just like the environment, is that a child process inherits it, meaning that they get a copy of it. The args, the current working directory in the environment, when they make changes to it, it doesn't propagate to the parent. So, all right, with that completes our first example. So we have 3 more to go, and then 1 we can review, which has already been written. One thing I wanted to add to the remainder of this example is that I added some of these comments actually. So essentially, when we did wait with output, the reason we had to use wait with output and not just wait is because when we called wait here, it'll consume the child process. So basically, we cannot, once we call wait, we can't get the standard out and standard error because we don't have a handle on the child anymore. So when we say wait with output, it actually returns a different type. So if we look at wait with output, we get the output, and when we look at wait, we get a exit status. So from the exit status, there's actually a really nice type state pattern in Rust where the types make it so that we can't do anything that we shouldn't be able to do. So wait returns a different data structure than wait with output. So wait with output returns a standard process output, and the wait method returns standard process exit status. So from exit status, there's no way to get the standard error and the standard output. But from standard process output, there is a way. So that's why we have access to .standard out and .standard error. And that's why we are able to then programmatically see what's inside of it. So so there you go. There's the comments cleaned up a little bit. So in this next example, we're going to do something a little bit different. Instead of simply spawning an external command like echo. So echo is a binary user bin echo. Should have mentioned that in the previous example. But yeah, echo is an external binary that we're launching. It's not an internal shell command. So this time, for the next example, we're going to launch cat. And cat takes input from standard in and then simply displays it to standard out. So we're going to show how we can actually use essentially pipe input from the shell that or whatever environment we're in, whatever process, to actually we can take standard out from, let's say in our example, a shell, and then put it into cat via our Rust program, which is going to be async. So it's a little bit more sophisticated than just running the echo binary. So here we have, there we go. So let's make a new file. Okay, this one, let me put some comments in here because this is really handy to have this ahead of time. So then I'll go over the comments first before actually writing the code. So let's see this. Actually, let's grab a bunch of imports as well. There we go. And then here we can just say, okay. Let's see. So So what we're doing is we're going to pipe, actually there's a way to disable these spelling errors using cspell directives, but I think it's like, let's see, cspell. I think it's like next line or something. Nope, that's not it. Okay. I keep forgetting. I have it written down somewhere. Let's see. Oh, I think it's cspell dot cc. I think it's like this. Yeah. And there's another directive to basically ignore the next line. This is just so when I guess it's a bit awkward. You know what? I'm just gonna add this manually to the spell checker. Anyway, but let's see. Let's do this. Uh-oh. Huh. Okay, so let's do this. There we go. So here we have, we're going to write a program where we can echo something from our shell. Echo is an external program. So we're using echo. We're giving it some command line arguments, and this echo-e is a fish shell syntax thing. Actually, let's see. Oh, it's not fish shell. Let's see. I think it's -e. Yeah, here we go. Enable interpretation of backslash escapes. So let's see, echo. I wonder if I do bash and do which echo. I wonder if that has. Oh, yeah, it has the same thing. Enable interpretation of backslash escapes. Okay, so that's good. That makes sense. This would be the same regardless of the shell because it's an external binary. Okay, so what we're saying to the echo program is that take this from standard in and then turn all the backslash ends into character turn line feeds and then dump it into standard out. So then this pipe, it's this whole thing basically gets run in parallel in the shell interpreter. So like if it's a fish or bash, this process spawns, then this process spawns, and they're both running in parallel, and then the output of this is mapped to the input of that. And this is the thing that we're writing here. So we need to basically then take the input that we get in this Rust process, and then we need to send it to the cat command. So basically, we're kind of mimicking this pipe functionality. Not mimicking. We're basically we're just taking input from like when input is sent to our processes standard in, we're just taking that and redirecting it to, or sending it to the cat command, which will then take it and dump it to standard out. So it's just a lot of redirection that's happening. So the output of this gets piped, the input of that, then the input of this is then programmatically sent to the cat, this thing. We create a process, the cat command, and then we sent the standard in of whatever we get to the cat program, and then yeah, so and then we use command.spawn, and then we read it standard out, and then yeah, so basically that's the so then we're basically reading the standard out of the of this command, the Tokio process command, and then that's just aggregating or accumulating the output from the cat program. So yeah, it's just creating a layer around cat. I mean, we could have just sent this directly to cat, but instead we're putting this intermediary of this async command exec2 example, which acts as kind of a buffer or middleman. So standard in goes in from the shell into this thing. This thing then goes and spawns a child process for cat, and then sends that standard in to the child process, captures its standard out, and then dumps it at the very end to the terminal. It's just a really, really roundabout way of showing how to capture input and output and use Tokio process command. So, oh yeah, this is also an interesting thing to note that we didn't talk about this before. So once a child process is spawned using Tokio process command, in both the standard library and Tokio, the behavior is similar, which means that the dropping does not imply cancellation. The spawn process will by default continue to execute even after the child handle. In this case, we do Tokio process child handle has been dropped. So yeah, so we have to explicitly clean up our child process. I think we did that here, yeah, when we did wait. So exactly, okay. So to get this convoluted example going, let's do this. And again, this is just to understand how to manipulate Tokio process command in a more sophisticated manner. So let's see, why is this duplicated? That's weird. Let's do this. There we go. Okay, so what do we have here? So what we're going to do first is we're going to create a new child process that runs cat. So this is nothing new. We've seen this before. Let's see. So we do child, and that's a Tokio process command new, and then cat. Okay, so this will launch the cat command, which is user bin cat, and then we're saying I want the standard in to be piped. I'm sorry, let's do this properly. I want the standard in to be inherited from the shell, so that's not going to be piped, so this one is inherited. And then the standard out is going to be piped, that's right, and the standard error is also inherited. Okay, that sounds about right. So now that we have this, we need to do, let's see. Oh yeah, so let's see that if we can get the standard out. So this is at this point been spawned, and we got the handle for the child process. So using this child struct, we can actually get the standard out from it. We haven't waited for it to finish executing. We will do that later. But for now, what we're going to do is grab the. This is the how you do it. It's called. Let me write this out. So we get the standard out from the child standard out. We just take it. And if we can't get the standard out, then we should just error out. So what we want to do is we want to say yet. Yep. There we go. Because we can't really continue until we actually. There's an easier way to do this. We can just say bail. Yeah, there we go. And that's a yet macro. So yeah, so essentially what we're saying is, hey, from this child struct, go ahead and take its standard out, and then we're going to do something with it later. We're going to basically grab the standard out that we get from this cat process that we spawned, and then we've basically taken whatever is our standard in for this process, the one that we're writing, async, what is this, command exec2, and that's going to be inherited. So whatever that's the standard in from the shell will inherit it. The standard out, we're going to almost buffer, if you want to think about it, in memory instead of dumping it to the terminal. And the standard error is going to be dumped to the terminal. We can also like do null here if we don't want to, if we don't really care about, you know, the standard error. So spawn, just because we've spawned it and we've taken the standard out, that actually doesn't mean that, this is a little bit confusing. That doesn't mean that we're done yet. So now this is a little bit strange. What we have to do is child task join handle. So what we do is we say Tokyo spawn, and what we're doing is, what is this? Okay. Okay, so what we're doing here is that we're saying we're spawning a task, and inside of that spawn task, we are awaiting the child to finish executing. So this is ensure the child process is spawned in the runtime so that it can make progress on its own while we await any output. So this is a little bit strange at first glance, and so what we want here is let's do this. That's status, and we don't really care about into diagnostic because the code of who are we returning to. This is Tokyo spawn, so we can ditch this and we can just say print line. There we go. That's better. So, and then what we can do is put some colors in there. So we can do something like that. So basically red. So if we have a problem, actually we should let's see. Yeah, so this one we're not returning anything because this is being spawned, this disclosure. So what we're saying is that, okay, go ahead and spawn this closure, and all that does is, you know, just wait for, call the wait on the child struct, which consumes it, and it returns a result. So this is result exit status, and then that's pretty much it. So this is result exit status, yeah, and then so this basically makes it so that we can continue. So there's going to be Tokyo is going to be running this task, and it's going to be polling on this thing. So here, what we can do is now that the cat process is doing work, because remember now this thing is the cat process, the child is doing work because it's been spawned using Tokyo process command. What we can now do is like use its standard out and read whatever output we're getting from standard out and dump it to our using print line. So we can say mute standard out reader. We just do a buff reader. So basically it takes the standard out here, which is the child standard out struct, which has let's say this thing, and which is pretty nice actually. It's just a clean distinction between child standard out and child standard in. So here what we do is that we can do this, call it child standard out because that's what it is. And then let's see. So we grab the child standard out reader, and then we basically turn this into a into lines. So that's just basically, instead of reading bytes, we're just saying that it's character return line feed delimited. So we can actually look at where's child. I think it's child standard out. Yeah, this one. Child has standard out. Yeah, handle for writing to the child standard input. I think the one we grabbed, partially the child is blocking yourself. Child. Oh, we just take it. Oh, okay. Yeah, that's what we did. It's saying that use take to avoid partially moving child and thus blocking yourself from calling functions on child while using standard in. Yeah, that makes sense. The handle from reading, blah blah blah. It's been captured. Yeah, so it's an because it's wrapped in option, we can take it. So okay, so I think we have that here, and now we're standard. So there it is, child standard out, and let's see. It implements read, so that's how we can. I think there's also, yeah, so because it implements a read trait, we can use buff reader. So if you look at the read trait, it just, we can basically get bytes from it. So yeah, okay, that makes sense. All right, so we got the reader to basically say child standard.reader. So now we can, instead of reading bytes, we can read lines, because it is, I mean, in this example, it is all text input and output, so this is reasonable. And then we can say, just keep grabbing items from this reader while this task is making progress, because we've spawned it. And then, because this now is launched as a separate task, right? So this is a green thread. This is our current thread. So this got kicked off. That's why there's a little rocket emoji to signify that this got spawned. And while this is making progress, we're just essentially on the current thread waiting around for this to sort of accumulate. And what we can do is do a little bit fancier output than that. We can say like this, and then finally we want, so that there's a clean exit, we want to wait for the we created this, we got this join handle for because we had spawned another green thread to await on the wait method, which returns the exit status. So this basically cleans all that up. So until this finishes, we're not gonna exit this loop. So let's run it. So let's see what happens. So if we run it, as you can see, it just sits there doing nothing. But if I say hi, notice it echoed it out. So this is the code that we just wrote right here in blue. So the blue is barely even legible. So let's change this color real quick. So let's do something like green or something. And let's run this from this terminal. So we could say run, and we can say hi. There we go. So green, and then we can say world foo bar. Now that's running as we expect, because we're just typing it in from whatever shell we've executed in. But what if we don't want to interactively type stuff? So we can just say echo e foo bar as, and then that'll be piped to. So let me show you what happens when I just do echo foo bar baz. So if I say echo foo bar baz, it just types foo bar baz, and at the end it puts a carriage return line feed. So if I do like that, there'll be 2 character line feeds. So instead I can just say, let's see, cargo run bin async command exec. And so what's happening here is that so the echo command, the process, the echo binary takes this, runs in parallel along with this process. And then what it does is that the echo program just grabs foo, sends it to its standard out. It reads it from argv, which is command line arguments, and then it sends foo with the character and line feed to standard out. Then this program that we wrote picks it up and sends it to the cat command, because we told it to inherit standard in when we had launched the child process. So that's roughly what's happening. And then the cat command then produces output, which is then programmatically captured by this program. So it's essentially, we're doing a really fancy version of this. You can imagine doing something like this. I mean, it doesn't make any sense in this context, but let's say instead we wanted a Rust program, not a cat program, but this Rust program is wrapping the cat program. So then we'd say cargo run. So yeah, and then because of that, we get this different output, foo bar baz, because this is the line that's generating that. And then we also have this child process exit status OK, which is right there. And honestly, this should not be red. This is actually green because this worked no problem. And here we can maybe make this magenta or something. What else we got? Cyan. Let's see if that looks any better. Yeah, there you go. So there, this is a bit of a convoluted example, but I think it's important to see like the nature of the nature of how Tokio process works and what all the different sort of things are that you have to consider. So if you look back at this rocket, that's what this docs were trying to sort of explain, and the reason there's this pipe that it's a shell thing, and if you want to get more background information on this part one of this video, or not this video, but this video, in this playlist, there's three videos in this Linux TTY. Where is it? This one. So there's three parts to this, and the first part has a lot of background knowledge. So if you scroll all the way to the very top, you can see. And by the way, this is going to end up as an article in Developer Life, which is, I think, shaping up to look like, where is it? Like that. It's essentially still working on it, but this README from this TTY crate is essentially I'm turning it into an article on Developer Life, and so this one will have 3 related videos, and this is the third one that is actually being recorded right now. So yeah, if you check out this video, then you can get you know, a better idea, I think, of like what the sort of the context is for most of the stuff. So yeah, that said, that completes the second example. So then after this we can do 2 more examples, and this is going to be a little more sophisticated. They kind of keep getting more and more sophisticated until the very last example, which I might actually do a separate video on this entirely, which is kind of creating a simple asynchronous shell, which is kind of like a wrapper on top of bash, but it still provides enough. There's still enough stuff in there. Like there's a line editor. There's a lot of things that have to be built just to be able to wrap bash. So, but if you don't want to wrap bash, you can wrap anything else, or you can provide a native, just a native implementation in Rust as well. So the flexibility is just pretty incredible. So yeah, so that completes the second example. One simplification that we could do to this program, which feels a little bit convoluted, is that what if we restructure the code such that we can avoid the use of the spawn? So one way to do that is that there's such a thing called wait with output, something we've used in previous example. Actually, here, wait with output, yeah. So what it does is that it simultaneously waits for the child to exit, and it collects all the remaining output, returning an output instance. So here, essentially, the standard in handle, if any, will be closed before waiting, avoids deadlock. That's nice. Standard are inherited from the parent, blah, blah, blah. And okay, cool. So if we read this, it ensures the child does not block waiting for input from the parent while the parent waits for child to exit. Yeah, that makes sense. So because we have this, what if we reorder the statements such that we could do something like, let's say we don't, we got the standard, okay, so let's say that what we would do is that here, where we're doing the Tokyo spawn, we would just do this, wait with output. Actually take this out entirely. So we get rid of this. Then we get rid of this. What we can do here is just this. Put that comment there. So, okay. So, and then we can actually just do this that way. Oops. Wait to diagnostic, and that way we just have the output. And here we can say output status, and that gives us the output status. Now what we can do here is that, because we're just we just basically created the child process, then we take its standard out, and then we just basically put it above a reader, and then while there's something to read, we read it and then print it. But so this is a while loop, so it's doing its thing as long as the end of EOF hasn't been sent by this child process. And then when this finishes and it gets an EOF, then it simply waits for the child to exit, and then this output actually also has the standard out, standard error, and everything in it. So I mean, we'd also put this after so let's run this and see if this works. So here we have that works. So we can do echo. Yep, that works. So here another variant of this could be where instead of taking the standard out from there, we can just take it from output. There's another variant. And oh, is that not standard? What is this? Oh, it's just a vec of U8. Oh, so what we could do is we could just grab output standard out, and then that what does that do? Okay, so this is giving us lines of a vec. So then we can say, nope, that's not it. Actually, Well, we could do this, a dot next line, then we wouldn't need this anymore because that's already happened. And then we can just say, oh, where's next line? Oh, result. Let's see. Await. Let's see. Actually, we can do it like this. Then that should achieve the same outcome. I don't know if it's less. Oh no, that didn't work. Why not? This is a vec of u8. You know what? We don't need to do this. We can just do this. We can just say so maybe we can do standard out, then we can just do from UTF lossy, something along these lines. Then here. Okay, let's run this and see what happens. We did wait with output. Oh, this does no longer needs to be able. Okay. The output of a finished process. This the data the process wrote to standard out. Huh. So wait with output. I wonder why that's not working, because here we did wait with output and then that worked. So what if we just, let's see, print line terminal. This is print. This one, let's see, so we have child standard out, handle for reading if it has been captured. You might find it helpful to avoid partially moving child and blocking yourself. So the docs are actually recommending we do it the previous way, using take. Interesting. I'm just curious to see what exactly is in standard out even. Oh, that actually doesn't even. So this didn't work, this one, because it's waiting for output and then that output is interactively typed in, I think. Yeah, I see. So that works, but this doesn't work. Wow, that's a subtlety. Okay, so I think this is not a very good approach, but here what's happening is that because the echo process is essentially non-interactive, it's dumping whatever it programmatically takes everything in this whatever's passed in the command line arguments argv, and then it sends it to async command exec2 process, and all of this is available kind of at the start. So when it waits for output, it basically gets all its output, finishes, and then it reports, okay, this was on standard out. But if we just run it interactively, so now the terminal's interactive, so I'm typing stuff, but like in order to sort of get this program to do anything, I have to press Control D. You didn't see that, but I had to press Control D. So let's do this. Presenter presentation mode. No. Screencast. Yeah, screencast. That's a strange name. So check this out. So if I do this and I say foo bar baz, nothing happens. But if I do Control D, EOF happens. Then this picks up at the end of this end of file, and then because now it's finished waiting, it's gotten its output, and then it can go ahead and dump it all at once here. So the nature of it is very different than the previous version that we had. So I actually like this. Let's see, this is actually a different variant of it. Kind of interesting experiment, but so this is not as interactive as the other one. This one is more like you type all your input, then you hit Control D, and then it will print results. This is why there is a need for taking the standard out ahead of time. So we can say non-interactive. Let's keep this as let's say one of the variants, and I think this might be the better one. So we say async main non-interactive, even though this is simpler. Oh, let me turn on this present screencast mode. So I think this one is, so here, let's close this. So this one I think is better. It doesn't have, there's no need to do a Tokio spawn. But here, if I do, it's interactive. So basically, because it's, I took the standard out ahead of time. It's a subtly different behavior because I took the standard out ahead of time before I told it to wait with output. So there's a task that's running here that's basically grabbing what it can from the standard out and dumping it to the terminal, but it's waiting as well. So that's the simultaneously wait. There you go. So there's 3 different ways of doing it. I'm not really sure which one is the better way. There's the most sort of, let's say this is simpler, and then here we have the most complicated way, which is the thing that we originally did. So I think that the nature of the simpler is the same as the main. It's just that there's no need to do a spawn. And then, but this one, the nature is very different. So here, the nature of this function is different to the 2 above. For example, if you run, let's say this function in a terminal, you have to terminate the input using, let's say, Control D, which is the EOF character, if you want to see anything displayed in the terminal's output. And then in the 2 variants above, output is captured in an async manner. Actually, not async, interactive manner, as it comes in from the user. Not user, from standard in. Very subtle distinction. It's kind of cool that we added this 3rd variant, but yeah, a lot of different ways of doing the same thing. So yeah, with that, now we can finish the 2nd example. In this next example, we're going to do something much more interesting. So the first 2 examples, we're just going to get a handle on how the Tokio process command works and how to handle like setting the standard in, standard out, standard error, spawning, and waiting for output. But now this next example is going to be all about how to spawn an external command, just like we have, like echo or cat or whatever, and then programmatically send it input and then programmatically capture its output. So essentially we're running an external command in a way that it doesn't actually dump anything into our terminal standard in or standard out. It's actually being orchestrated or controlled entirely through Rust code, and it's happening asynchronously. So that's pretty exciting. Let's do that. Let's see. The other stuff was just kind of like prep to get to this one. So let's do this. Okay. So here, let me actually grab. I have a bunch of comments which will guide us. So here we go. And let's do this. And I guess we can just say okay. And yeah, okay. So let's see what's going on here. So this is, we're going to write a program that programmatically provides input to standard in, and it gets output from standard out. And these are all like Rust structs that we're going to be, essentially Rust data structures that we're going to be sending to this process and capturing the output as a struct, basically. I think it's just going to be a string. So this example is similar to the one just before it, but we're not piping, so we're not relying on the parent process to do any kind of piping. So here even though we're still going to spawn, let's see, we're still going to spawn cat. Here we're just going to we choose in Rust what data to basically send into this command. So we're gonna we're gonna basically grab its standard out, and then the standard in is what we're gonna be asynchronously pushing data so that it ends up inside of the cat process. So the spawn is the same as before. However, these are different. Now we're going to be actually Tokio spawning two separate tasks. This is so that the task or the green thread that's actually generating input can run at the same time as the task that's monitoring the child's progress, basically. So it's essentially we spawn a task where we will do wait, and we'll call wait, and that's in a separate green thread, and there's another green thread to generate data that we're going to be feeding via standard in to this child process that we spawn. And then in the current task, we're just going to grab the standard out of this child process and dump it interactively, meaning that as it's happening, we're going to see that whenever something is written by our green thread here, we actually see the output to the terminal. So, and the same rules apply for killing child processes. So this is something worth reading, where unlike the future paradigm of dropping implies cancellation, a spawn process will continue to execute even after the child handle has been dropped. So we have to basically be explicit about terminating it. Okay, so the first thing we want to do is just like what we've been doing in the past, nothing too interesting here. So we create a new command. We tell it to spawn the which cat, this thing, user bin cat, and these are, so for the standard in, we say that the standard in is piped, that standard out is piped, and the standard error in this case is inherited from the parent process. So basically whatever we have in the whatever the deal is with this process. So this, if we don't care about standard error, we can actually just put null. This way, like, we don't particularly care what it's, we don't really monitor the standard error. So, and then we don't want to pollute it. We don't want it to pollute our terminal either. So this is a way of spawning this process, essentially this child process that's running cat, grabbing the handle to it asynchronously, and then making it so that its standard in it's standard out and standard error totally managed by us. So let's make another array, and this one is going to be a bunch of data that one of our green threads is going to be sending to this child process. So that's this, and then so now, like we've seen before, we need to grab the standard in and the standard out for this child process. We've done it before for standard out, so now we're going to do it for standard in and standard out. So this is roughly what that looks like. So basically, we have a child standard out, a child standard in. Essentially, what we're doing is we're just calling child.standardout.take, and then child.standardin.take, and then we're just returning it as a tuple. And if there's any problems, then we just bail. So actually, this is one way to do it. This is another way to do it. So I think it's a little bit cleaner to read, since it's, that facility is provided. Why not use it? So this is just a kind of like very simple way to initialize the things, and then after that, let's see, I think we have to let's see, what do we have to do? Let me grab this real quick. So this one, 1 second, there we go. Okay, so now at this point we have to spawn like 2 tasks, 2 green threads. So let's do this. So let's say we're going to do a join handle for the child task. That's going to be like something like spawn child process. And so in order to spawn the child process, we need to give it the child struct. And since we've moved the standard out and standard in out of this child, we can safely move it into this function we haven't written yet. Then another one we're going to do is we're going to say join handle. This one is going to be provide, let's see, input task. So this one, provide input task. So this one is going to be spawn provide input task. So there you go. And so that's roughly, and this one is actually going to take a standard in because it needs to write to standard in, and the input, which is just basically just some strings that it's gonna write to the child process. So obviously we haven't created these functions yet. That's next. And then let's see. So actually we can do. Let's see. Child task and let's see, join handle. Okay. So far so good. So now let's do this. Let's create this one first. This one's going to be pretty straightforward, actually. So this one's going to be spawn child process, which will take that. And I think that's right. It just, yeah, waits for the result exit status. Let's see, result exit status. And then it just, yeah, prints prints the output when it's done. Okay, so that's good. And let's see, does that match up? Yes, it does. Okay, and that returns the join handle from Tokyo spawn, which we will do something with down the line. Actually, why do we do this? This is to do. We're gonna let's see, read from the standard out of the child process, and here we're going to wait for the child task to complete, and we're going to do Tokyo join macro, and here we're going to dump those 2 join handles, and that will be that. So yeah, this is a big to-do left, and one more. So let's do this spawn provide input. Let's do that. Let's see, did we do, yeah, cat. Okay, so let's do fn spawn provide input, and this one is taking the standard in and the input, which is just a slice of ampersand strs, and let's see, we do Tokyo spawn. Let's see, we could do this actually where it just goes right all. Actually, let's do this instead of doing this. Let's do this. What we can do is Tokyo spawn input. Let's see. Let's do this. Let's see, join. So let's see. Actually, let's do this. Okay. So what I want to do is take this string slice and just turn it into a vec of string. Then I want to do this, say something like, I want to do standard in. So this is the standard in of the child process. So we're going to write to the standard of the child process all the bytes in, let's say, input join with, like that. There we go. And I'm going to wait it, and I don't really care about the success or failure, so forget about that. And so this will write the input to the standard in of the child process, so the in its entirety. And the only reason I think for doing this is just to turn it into, I wonder if I can just do this without that. No. Yeah, exactly. And the reason for that is that this is a string slice, and Tokyo spawn, this will be moved in there, so that's not going to work. That's why we have to basically make an owned version of this. You know, I could just do this. I can just say, why not just do it here? Yeah, let's just do that. And then we can just say, in fact, why don't we just do this as bytes? And that's that. There you go. So, did you not like this? What is the problem? Oh, I see. Never mind. Yeah, this is better to do it this way, because I think this can take a slice. So, okay. And this is return to slice. So, okay. Let's see. So we do Tokyo spawn async move, and I think what we can do here is, let's see, we're returning. Let's see. I don't think we do. Let's see. Do we do any write all? Oh, and then let's do an end of file. So we need to do this. We need to drop the handle to signal EOF to the child process. So this is important. Yeah, that's an important line there. And then here we can just say print line, and we're just saying that, actually let's do this better with, yeah, so we're just saying that finish providing, and I think we just do input. I don't know why this is, yeah. Perfect. So that should do the trick. And here we are doing a Tokyo spawn. So that's what the rocket is, and it's a green thread. And here also we're doing a Tokyo spawn, so we can put a rocket there as well. So let's do this and here. Okay. So when we spawn provide input, we got this, we take the input, we write all of it to the child process, we drop it to signal end of file, and I think that's pretty much it. And then we just basically, this also returns the handle, so this is returned. Okay, and I think that handles these two yeah, that should run actually if we run it right now. I don't think we'll see anything except that, you know, child process exited and finish providing it, but let's run it and see what happens. We haven't done anything with standard out because at this point we haven't read from the standard out, so we will need to do that probably in a separate function. So let's see if this runs at least this far. Still compiling. That looks promising. So let's do this. Cargo run. I think it's 3. Let's see. Let's move this to the end. Okay, so yeah, I think that worked. So there you go. Finished providing input and end of file to the child process. And let's see, where's that? I think it was right there. Yeah. So here, actually, what we can do is do debug for this thing basically. We can also do it, I think, like that. If we didn't want to do this, you know what? That's fine. That's okay. Okay, let's run this again. That should do. Yeah, hello. Oops, I don't think we need to escape it because that's what this does. There we go. So finish providing input and end of file to child process, and then let's see. Why don't we do input? How would I do this as blue or something? Let's see if that works. Oh no, because it's debug output, that's not gonna work. That's okay. Actually, if we wanted to do this, we'd have to do it like this. I don't know if it's worth it, but we would say something like, let's see, output message equals format, something like we would grab this and then the input and then say that this is blue, and so that's like basically the output message, and then here we would say like that output message. It's always confusing, never gets easy. Okay, let's see if that works. Nope, it didn't work. So what we need to do is debug format. Let's see if that works. Yes, that works. Okay, so and then we can just do this. So that wasn't actually that hard. Just figuring out what to nest into what, that's usually the problem. Okay, so we have one, actually this one, since this is, I'm going to put a rocket in here because why not? That's one of the green threads, and I think this one is also a green thread. So check it out. So here we have finish providing input and end of file, blah, blah, blah. This is the spawn provide input. So let's do this. And this one is spawn child process. So let's do that. There we go. So we spawn provide input. It does finishing providing input and end of file, blah, 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 to the standard in, which is these bytes. And then spawn child process. It's just saying that it worked, no problem. Like there was no errors, but we don't have any output. So that means cat said, it's all good, I got the input, but we have no idea what input it got. So that's not that helpful. So let's Let's make another function then. So let's see, we can say fn, what should we call this? Not child process. This one can be read standard out, maybe. And what we can do here is, let's do this. I don't know that we need a join handle for this, because we can run this on the current thread. We don't need to spawn a new thread for this one. So this one would be something like, this one needs to be async. So we do standard out reader. So we take our standard out, which we will pass in here. And here we can just say read standard out, something like that. That this function is generating this output. So this one, and basically this is what's coming out of cat essentially. So maybe what we can do is, so if this is the arrow for going in, maybe what we can do is like maybe doing something like this right arrow. So this is like rightwards hand, and this one we can just say leftward hand. This is like what we got from cat, and this is what we sent to cat. Hopefully this iconography makes any sense. Oh, and we didn't call it, so let's do this. Read standard out. That's it. So this is the, yeah. So, and then we join. Yeah. So this is spawn tasks 2, and here we can say on the current thread. So we're not spawning a new task with this. We could, but there's no need, because we just have to join it anyway. That's why. So if we did, so for example, if we did the, actually something is wrong here. We can do result yet. Oh, I see. So we just need okay. Okay, so we're just basically creating a buffered reader, and we're just reading each line and putting it here. And here it's, we don't really, care that it's. There we go. Okay, so yeah, so we've wired it together. I guess we could also do. I mean, this wouldn't. We could do this. We could do Tokyo spawn, and then async move, and then we could do like this. But I don't know. We could say let join handle. So we could say join handle, something like that. But oh, and this would be. I think I've typed join handle, so not. Like that. Okay. I don't know that this is necessary. What is yet result? Is that not what we are doing? Yet result, join handle, and join handle. This function should return a result or option. Oh, I see. So this is inside the Tokyo spawn. So you know what? Let's just undo this. Because we lose the ability to return the error or whatever. So here we can just roll it back. So no need for that. And we can just say okay. All right. I mean, we don't really need. If we need it, we could spawn it as a separate green thread, but as it stands right now, it's unnecessary, and we do not need this async move anymore. Ditch all this. There we go. Okay, let's see if it runs. Look at that. Read underscore standard out hello, and read underscore standard out Nadia. So this is basically 2 of the strings that we generated from there, and then this one, I think got standard in, so 2 more spaces because Unicode width reasons. Because this emoji's actually display width is much wider than a char. So I mean ASCII or NC char. So yeah, so there you go, it's working. And then it goes at the end, it's like read, and so read standard out is not happening. It's just on the main thread. So if we wanted to make it explicit, we could just do something like, that's the current thread basically. So whatever the current thread is that's running. And there we go. That's now we're programmatically manipulating the input and the output from the cat process, which has been spawned using Tokio, and it's being managed asynchronously. The only thing is that we did not spawn a join handle. I mean, we didn't spawn a Tokio. We don't use Tokio spawn here because there's no real need to, because we're just basically on the current thread awaiting these two to finish anyway. So that's why there is no need to do that. But if we needed to, it's not a big deal. We just lose the ability to return the result. Basically, because we've just returned a join handle of which takes a generic over a unit type. So, okay, that was actually pretty quick compared to the other ones. And then, yeah, so that ends this third example. In this final example, we're going to take essentially programmatically create a pipe of sorts where we take the programmatically spawn one process, and then we take its output and then redirect it to the standard in of another process, which is also programmatically spawned. So to do that, let's create one more example. Let's see. So this one is going to be the fourth example and the final one. Here we go. There's actually one more example I will briefly cover. I mean, it won't be live coding, but I may do a separate video just on that example later. It's the implementation of a shell, asynchronous shell. So let's see. I'll just show the code and provide that. It's an example in the Rebel terminal async repo. Let's see. Okay, so let's see. So this is the gist of what we're going to do. Is we're going to mimic essentially how we might implement like the pipe in a shell. I mean, we're literally not going to do this, but it's functionally it will be very similar. So what we're going to do is we're going to spawn an echo command with the argument hello world, just like we did at the very start, our first example. Then we'll get its standard out. Then, secondly, we'll spawn another command. This is the tr command, which it's a text replace command, which we will essentially take the output of the echo command, pipe it into the tr command, and it should produce some output. So we'll spawn that as well. Then we will join them both and wait for them to both to complete, and then we'll capture the output of the command, the final output, and then we're gonna basically see the output of echo flow into the input of tr, and then we'll see the output of tr that we're going to read programmatically and display to the terminal. So yeah, that's essentially kind of, imagine if we had done actually this one where we had an echo piped into cargo run. Imagine if this was echo piped into tr with some arguments, only instead of using a shell, we're going to do this programmatically. It'll give us like more experience in actually handling or getting more exposure to how this works, the standard process command and child. So we've got these. Okay, so let's start by doing this. So we're going to do, let's stub this out. So what we expect is we're going to first spawn the echo command and get its standard out. And we need its standard out because we're going to take the standard out of this command and then pipe it into the standard in of the tr command. Then we're going to do spawn the tr command and pass exactly and provide the standard out of echo to standard in. That's exactly right. So let's do this. So let's say we're gonna do we're gonna get the child standard out of echo and the join handle for the echo task, and we're gonna get that from this spawn child echo and get standard out. Oh wait, okay. And I don't think we need to wait because we can just do this because it's going to be a spawn, so we don't need to wait. So we've got this. We need to write this function, and then we need to write this function. Similarly speaking, we're going to get the child standard out and the join handle for tr, and we're going to spawn the child tr. And let's see, pipe to standard in. So see, provide standard in, pipe to standard in. I think I like, let's see, pipe. I think we're going to say provide standard in. That sounds better. Okay. Okay, and so none of this is written, and then the rest of it is going to be, oh, and then we got to wait actually, let's see, wait for both child processes to complete. So here we're going to do nothing equals Tokyo join these things. Okay, and then actually we're going to do read the output of the tr command and make assertions. And very finally we're going to do print the output of the tr command. Okay, so this is to do. And also to do. Okay, so let's do this. This is going to be spawn the echo command. So here's some comments for this thing. It's going to be fn spawn, let's see, child echo and get standard out, and it's going to take a couple arguments. Let's see, no, it's going to take actually, let's see, oh, actually it doesn't take any arguments, it just returns oh yeah, never mind, it just simply returns the it simply returns what it said. So it returns a result containing a tuple, which is the if you remember this, it's going to be the child standard out right there, and it's going to be the join handle containing actually we don't need the child, this is just going to be unit. And so we can actually kind of, you think about it, we can do type here, you know, we can do like this is type, let's say, which one is this one? Echo result is that, just to kind of make it a little bit easier to read. So we can do echo result. We can rename these later. Okay, echo result, and then here we can also put echo result. All right, and then we'll do something similar for this one, but let's finish this first. So here, let's see, let's do this as well. Okay, actually, let's just we're going to do that anyway. So let's just do this. Okay. So first thing we're going to do is println. So this is spawn child echo and get standard out. So we know we got to return a standard out and a join handle. So let's do this. Trash all this. Let's do join handle. Okay, so this one we're gonna do, actually no, this is join handle. So let's spawn the child process. Actually, this one spawn child. I guess this is okay. I can do rocket here. Okay, so we're spawning the child and the child process for echo. So we say, okay, child echo. We got echo. We do hello world, and then we do piped. That's right. So since, I mean, we could be explicit and we can say standard in. We're not going to do anything null, and we can say standard error. We can do null if we wanted to be explicit, and then this way we know, like, you know, explicitly, like what we're doing, and then we need to take the let's see, take the standard of the echo child process. So we can just say, and this will be let child standard out equals child echo. We're going to do dot standard out. That's the option. We're going to take the value, and then we're going to say okay, or if we can't, then we're going to do miet, and well, we can say failed to capture standard out of child process echo child process. There we go. Okay, now we have a child standard out, which we can return here, and we still need why is this right? Let's see. Okay, child standard out. Okay, perfect. And then we need join handle, so we can do this exactly. So we do join handle, and we say child echo we don't need to say this, that it exited or whatever, because we'll see the output actually, and we don't even need the exit status. We're simply going to do this, and this one, you know, we don't even need to do any print lines, so I think this is just keep it like simple and clean. There we go. So we have our first function. Okay, now we gotta do something similar for the second one. So let's see, let's do this. We can say, let's see, we're gonna do, I think we need a very similar kind of thing, but this time, I think it's gonna be, I have some comments that we can put here. This time it'll be fn spawn child tr. So now we know from the name we need to give a standard in. I mean, we need to give it a standard out of the child standard out of echo. So which is going to be this is standard out from other child, which is going to be Tokyo process, actually child standard out. So that's nice. We have an exact type, and we are going to return yet result of type actually let's go tr result. There we go. Okay, and we're going to say okay here. TR result is not defined, so we're going to define that here. Type TR. Actually, let's just do this. This is also going to be TR result. So now we can do type TR result is that. Yeah, standard out, and this one was also standard out. Okay, so it's a standard out for the tr command that we're going to be using. Okay, and then let's see, the first one we took the standard out of the echo command and returned it. And then in this one, we grab the standard out from echo, pass it to the standard in of this thing, and we get the standard out from it. So this is the standard out of the tr command, basically, if that makes sense. So this is the standard out of the echo command, and this is the standard out of the tr command. And then we're going to read the output of the tr command, which is the standard out tr. Let's see, from standard out tr. Okay. I don't think we have this. This is just to join. Okay, so here. The result. Oh, right. It needs a tr result, so that's not gonna. That's why it's just to do. Okay, so is this compiling? Yes, it is. All right, excellent. So now we can do the tr command. Actually, let's do this. We did the echo command first, so we'll do the tr command second. All right. So one thing we need to do is we need to convert standard out from other child, which is of type standard out, into, which is let's say Tokyo process child, and then we need to say into the standard in, basically. Yeah, do a standard in. Convert this thing. This is of type into, which will then be passed into the standard in, then to pass actually, so it can be provided to the standard of the tr child, actually tr command, so that's right. Okay, so that's basically this is what we're going to have to do. So the first thing we will do is, let's see, there is actually a very easy way to do this. We just do standard out from the other child. We give it a type, which is this, and then we just say try into. So the crate actually provides a way to convert child standard out into standard process standard IO, which is super handy. So that was taken care of us by Tokio. Very, very nice. So now we're going to spawn the child process. So we're going to say, that's right, new TRAZ, and then we're going to do standard in is standard out from the other child. This is this thing. I mean, could have done it this way in line, but this is a little bit easier to understand the type conversion. And then the standard out of this is going to be piped. That's exactly right. So we're going to do null, and then we're going to spawn into diagnostic. That's right. Now that's half done. So we can do this. We can say okay. We can say let's see. So actually, we haven't taken the standard outs yet, and we haven't generated. So what we can do is let's do this. We can say get the. Actually, let's see, we're going to grab the standard out of the child process. We're going to say take the child process. We say let child standard out. Yet something like that. And then the same thing as before. Yeah, so we're going to spawn that, and then we're just going to return that. There we go. So now we have these two functions sorted. So we got echo result, then we got tr result, and as you can see, this is not used. So this is a hint that we're going to be working with this next. And we've actually seen this already. We had a function, I think here, where we read this one. I think we can. Let me see if we can just copy that same. Yeah, can basically copy this. So we can do, actually, you know what, let's just write it again. It's not a big deal. So we're going to do read the output of and make assertions. So let's do this. So we're going to say let mute output is new vec, and then we're going to say Tokyo IO buff reader. So we're going to make a new buff reader out of this child standard out, this one. And then we're going to read to the end, and we're going to dump it in this output thing. Awaited diagnostic, and that's the thing. So, I mean, you know, if we want it to be like, we could do it like this, let it equals, then we can just say, I don't know if this is more readable, but we can do it this way. So put something like that. So there's our buffer basically, or we can say buff. So we have a buffer. We tell Tokyo to fill that buffer using everything that's in the child standard app as it's coming. So this is going to be interactive, so to speak, not like at the end of everything. As output comes in from the first command, it's going to be piped into the second command, and then we're going to be reading that immediately as it's available, one line at a time. So that's what this does. So let's see, and then finally we can make assertion. So we can say, let's see, the assertion is going to be assert eq hello world, because the input that we gave it, where is it? Let's do this. Let's say const input is this, so we can just say, there we go. So we're giving it that input, and so we can say assert is, I guess we can just say input to owned uppercase. To uppercase. Oh, I see. So this won't be a vec. This will just be a new string. Oh, what is happening? Oh, okay. This is going to be bytes. So that's output is vec. Oh, I see. I see. So we can say to, let's say, Well, so the output, we can say string from UTF-8 lossy, and then, so we're gonna, what is this? There we go. Wow, that was slightly convoluted. What this means is that we're just gonna assert that we're gonna assert that the output that we get. Actually, let's do this. This might be more readable. I mean, we could do this. We could say to, let's see, as bytes, and then we don't need to do the lossy thing. There we go. There, this is, so we're taking the input, which is lowercase, and then we're uppercasing it, turning it into bytes, and then we're saying, okay, it should do the same as what we get from here. And then as the final step, we can print. So here we can say, just do a little bit more fancy variant of that with some colors. So do blue output. Okay. So let's see if this works. Let's run this. I see. This is not working because there needs to be a \n. That is missing. So the input is hello world. Oh boy. So we're gonna do something like this. This is pretty awful. Input, and then we're gonna say \n. So that is a string. Okay, so that is a string, and so now we need to turn this vec. So here we can say string from UTF-8 lossy, and that should work. Okay, all right, that should work. Nope. I see. That's right. This is actually correct. This is, we're going to do to uppercase because that's what we're telling TR to do. So to uppercase. How about this? Let's do this. Let's expected output is this thing, basically. And so we're going to say expected output. So we're saying that the expected output is going to be the uppercased input with the \n at the end of it, and that we expect it to be exactly the same as output, which is what we're getting by reading the standard out of the tr command. Whew. And let's run this again. There we go. Output is hello world. Ta-da! So that, in a nutshell, is the final example in the series. So we've now gone through all the different 4 versions, and then there's one more left where I'll just show the example, but I won't actually live code it, and then we'll wrap for this particular video after that. This final example is quite complicated, and I'm actually not going to do a live coding version of this in this video. I might actually take this upon as a topic of a separate video. This example is in the it's actually I've included in the here in the README for this repo, which is being turned into the develop life article. Is I think down here somewhere, which currently it's a to-do, but it'll be done by the time this video is posted. So here we have the rebel terminal async repo, and the example is called shell async rust. So again, I'm not going to do a live coding version of this. This is more like, please play with it and see if you're interested, you know, how this works. But I will do a separate video on this in detail because it's quite big. It, it basically allows you to create a REPL, which is asynchronous, and it's in Rust. So it's a non-blocking read line, and the standard IO, the standard out is also asynchronous, and it supports spinners and pause and resume and all kinds of sophisticated functionality. I can show you this real quick. This is part of the Rebel terminal async crate. So, oops, it's right here. Rebel open core terminal async. And so if we run the examples like that, you can see like this is a REPL. So start task 1, start task 2. And as you can see, as I am, you know, running these commands, I can edit the this line editor thing. So it's pretty handy. And then we can do something like spinner. And while the spinner is spinning, we can it's all the there's a bunch of messages that were being queued in the background, which didn't clobber the input at all. And when the spinner completed, I was able to see the output. If I can also, if I want, I can actually Control C and kill the spinner sooner rather than later, but that won't exit the whole program. Super cool. So if I hit Control C again, that'll exit the whole program. But if I run it again, if I hit Control D or end of file, that'll also exit the program. So yeah, it's pretty cool. You can even create your own asynchronous commands like tree. So if you run this in a in a folder which has a lot of files in it and a lot of folders in it, subfolders and files, then you'll see like a lot of output. And it's actually intentionally delayed so that you can kind of see the kind of gradual scrolling effect that's happening. So yeah, take it for a spin. You know, if you wanted to create your own REPL or you wanted to create your own shell, this is a good starting point. So so that's the purely the REPL side of it. So if you wanted to make your own shell, that's also a good starting point. That's the main example. But this is the one I wanted to show you, is something called shell async. So this is the PID of the bash process, which has been spawned for the lifetime of this program. So while this program, this process, shell async, is running, this PID it's a child bash process which is running in the background. It's not really running in the background, it's running as a child process. And programmatically it's been spawned. And when I type things in here, so I say export name equals Nadia, and I say echo $name, this actually ends up producing this is sent to that bash process, the long-running bash process, and it produces the output. So here I can also say things like cwd. So here you can see like there's the current working directory, pwd, there's the cwd, obviously this is a as you can see, command not found. So well, it doesn't work, but pwd works. So so yeah, this is basically running a bash process inside of this thing. And I can just like write other things. Whatever I write, it's going to be sent as soon as I hit enter to the bash process. The bash process will use these the bytes that I typed in as input. It'll process those, produce output, which will then be piped and sent to this terminal async window and be rendered. So that's how this works. It's very cool. Try it out. Yeah, and so you can just clone the Rebel open core repo and then go to the terminal async folder and run that example. So the way it works is that there's a broadcast channel that is created to signal shutdown across the whole program. The terminal async is used to write to the terminal, and it also provides a way to collect user input. Then the Tokio process child is used to spawn the bash process, which is long running, and it's used to interact with it. So we grab it, so we take its standard in, we take its standard out, and then when something gets typed into this terminal async, those bytes are then written to the standard in of the bash process. Then there's another task that's spawned, which reads the output from the child process and displays it. So it's like kind of a culmination of all the different things that we've done. And then there's stuff like what happens when you type exit or Control D and things like that. So Here's a little bit like the test case. You say, you can export, not export. You can say message equals whatever, hello Nadia, and then you can say echo message, and that'll work. And this is the output that you would expect. Yeah, and this is basically like if you were to kill all -9 bash and shell async, then it'll essentially take down all if this is the only thing running, let's say it'll take down the bash from here and the shell async, which is this program. So let's see, and this is roughly the way the code, as you can see it. It's kind of similar to some of the other things that we've done, but it's a lot more complicated because there's a whole other mechanism. Like in this last example we did, the input was hard coded, but this is a more generalized form of this, if you want to think of it that way, with a much more sophisticated REPL interface and line editor and all sorts of things. But I mean, it's essentially the logic is very similar. So yeah, please take a look, and I will do an in-depth video on this separately, because this in itself is like a whole other video. There's a whole lot of stuff going on in here. But yeah, so please take a look. Yeah, we have a Discord, so if you have any questions, thoughts, comments, please do put it on the Discord. And yeah, if you like this video, please give us a thumbs up. It helps me grow the channel. Please subscribe. That way you'll be notified when I release new videos. I think this is the third of a 3-part series. I'm intending to, I think I'm going to publish them all at the same time. And there's a blog post coming on Developer Life. If you haven't already, please go to developerlife.com and subscribe. I usually don't post that often, like maybe 1 to 2 a month. You might get an email, and like for example for this video, I will take the blog post and the 3 videos and put it in this, send out an email to the subscribers. But yeah, and the YouTube channel is right here. So there's a whole lot of really good videos here. If you haven't already, please check these out. This particular one is a kind of a deep dive in the TTY space, but there's a whole host of other things that we have in Rust. So right there. And if you have ideas for videos that you want to see, please do share in the Discord. And I think at some point I do want to start a podcast, which is in this channel itself, related to startup topics and things like entrepreneurship, hiring for startups, culture at startups, and just companies in general. And then in terms of the live coding videos, I have another one in the works, which is on lifetimes, so stay tuned to that. Then I have another one on, I think, clap colorization, and I have another one on Ubuntu and keyboard shortcuts. So these are all kind of something to look forward to over the next couple of weeks and maybe a month or 2. Thank you again for watching. I hope this was useful, and yeah, I'll see you in the next one.